next speaker is Dr. Rebecca Silton, who is an assistant professor in the psychology department here at Loyola. She's also the director of the Wellbeing and Emotion Lab here. She received her BA in psychology from Macalester College and her PhD in clinical psychology from the University of Illinois at Urbana-Champaign. Dr. Silton is a clinical scientist with expertise in studying affect and cognition using EEG. She applies innovative EEG methods to understand the function of neural structures that are related to affective experiences. Her research aims to identify basic neural mechanisms in the intersection of positive affect and cognitive function in order to understand disorders characterized by low positive affect, such as depression, postpartum depression, and chronic pain disorders. Her research also aims to advance neuroscience-informed interventions that target modifiable brain structures that implement affect in order to promote physical well-being and psychological vitality. Let's welcome Professor Silton.
Thanks, Joe. Give me just a second to get set up here. Great. Well, first I just want to begin with thanks to Michael, Joe, and Hans for inviting me to be here today. And of course, thanks to the Hank Center for Catholic Intellectual Heritage as well for sponsoring this event. I always welcome opportunities to be involved in interdisciplinary endeavors. I find that that's where we learn, is at the margins of our discipline and working to communicate with other people. The dean in his opening remarks said, you know, if I was an undergrad today, I would major in neuroscience. And our neuroscience major is alive and well, and it continues to grow. But I would also add to that it's important for our neuroscience students to learn how to collaborate and be interdisciplinary and to work together. To echo the sentiments of the biologist E.O. Wilson, he coined the term consilience, suggesting that in order to move science forward, we have to be interdisciplinary. And so that's one of the reasons I'm really excited to be here today, is to offer an interdisciplinary perspective to the conversation. And you can see I titled my talk, The Mind and Brain of Embodied Selves. And as Pauline said earlier today, you don't have a body, you are your body. I'm going to continue to develop that argument, but from a cognitive and affective neuroscience perspective. So let me just begin with saying that I want to just provide a little background about nomenclature. Similar to the sentiments in the first panel of speakers, I also Googled the term personhood. And I Googled personhood in psychology and all sorts of things. And I couldn't find a ton of literature around personhood in psychology. However, there's a long history of using the term self and selfhood in our field. So I'm going to continue to use that term as well throughout my talk. And I'm going to go through and I'll explain all these terms in a minute. But before that, I want everyone to take a minute to engage in a thought experiment with me, okay? All right. So if you could remove yourself from your body so that you could give yourself to someone else, where would you locate yourself? What would it look like? If you're successful in removing yourself and putting it in someone else's body, is it still your own self? Or is it someone else's self? And I'd like to add to this as well. We could think about this question within our own bodies. The body is dynamic, right? How do you locate your own self, or as I will argue, selves, in a changing body? Our bodies are perpetually aging. And what does that mean in terms of selfhood? I may be presumably able-bodied right now, but something could happen this evening and I may be disabled and existing in a disabled body tomorrow, right? So trying to encapsulate a selfhood that can interact with changing bodies is critical to my conception here. So in this thought experiment, I came up with it actually walking my 7-year-old to school. And it turns out that 7-year-olds make for really excellent philosophers. And I asked my son these questions as we were walking that I just asked you, and he really couldn't come up with an answer for most of everything. He tried hard, though. So, and although in the answers he generated, he really firmly reified my suspicion that the self somehow exists within our body, and if we transplant it to someone else's body, it becomes a different and unique self, because each body interfaces and perceives the world in a unique way. So I'm going to argue, just briefly, that embodied selves are dynamic, multifaceted, interconnected, social, emotional, and reconstructed. And I think you already have a sense of what I mean by dynamic. And I want to propose that embodied selves refer to the notion that the self is not just an abstract concept, but rather selves reflect lived, recreated, and imagined experiences that again exist within a human body that interact with other selves within that body, and interact with environmental stimuli that are external to the body as well. And these external stimuli may include the selves of other people, among other things. And the body plays a role in shaping the brain. The brain is part of the body, so it might be more accurate to say the body plays a role in shaping the mind, and the cognitions and emotions that are going to give rise to selfhood. And I've already used the term selves instead of self, and I would like to argue for a multifaceted conceptualization of selfhood. And the mind gives way to multiple selves. These selves are past, present, and future, or we could say imagined selves. And so to some extent, someone asked earlier kind of a question around the temporal course of personhood. And so as humans, we have the capacity to look back in the past, think about what we're like in the present, and look towards the future. However, the way our mind works with regard to memory, all of this is recreated and reconstructed. And I can talk more about that later. So we have these multifaceted selves. And I want to say the concept of a multifaceted self is not new. It can be traced back to William James, and I'm sure other philosophers as well. I'll talk about that in a minute. And in psychopathology, in its most extreme form, the presentation of multiple selves can be expressed in a form of psychopathology that's otherwise known as dissociative identity disorder, or DID. This was formerly known as multiple personality disorder. However, for most people, experiencing multiple selves or characters or identities exists within a normative context. So, for example, depending on the context, I have different identities that may come to the forefront. So perhaps in some contexts, I'm going to be a mother. In other contexts, a daughter. In others, a scholar or a teacher. And you could argue that I have core or minimal selves that may link these identities. They're arguably unique. Each schema that I'm in, each identity that I am, each self-schema is going to prime how I focus my attention or my emotions. So for example, maybe my mother self-identity is primed, and I may be inadvertently, say I'm with my children, scanning my world to look out for danger in order to keep my offspring safe, right? That would be one example of how the self is going to act as an attentional filter. I'm also going to argue that per human nature, we are interconnected. Our selves are interconnected. Our narratives, our characters, our identities that contribute to the construction of our selfhood interact, again, with our experience of these ever-changing selves with one another. And our interconnected selves, how I identify myself relative to another person can change. And again, all these interconnections are malleable. And we are also fundamentally social creatures. So as I noted earlier, our self is going to exist in relation to other bodies, other selves as well. And emotional. I spent a lot of time studying human affect, and I've been tasked on a different project to try and figure out, do humans have affect as well? And this, of course, has implications for animal welfare. And I'm not ready to say that emotions are uniquely human, but there are emotions that I experience that I'm not convinced that certain non-human species can experience. And emotion really focuses our attention on specific aspects of our reality that, again, feeds into creating our different selves. And our selves are reconstructed. So again, the way the brain is going to recall memories is always going to be in a reconstructed manner. And so our past, our present, and our future selves are going to emerge from these reconstructed narratives that, again, are going to change based on context. So when the mind recalls a memory, again, it's not regenerated in a quote-unquote pure form. Rather, it's going to be regenerated as a reconstructed memory. Each time that memory is recalled, again, it's going to be reconstructed again and again. So it's a very iterative process. And you could think about this just as a digital camera is going to convert analog or real-time to digital or reconstructed format that's, again, constrained by whatever the specs of the lens that you're looking through, or even the person behind the camera is shot. So you could say, in a sense, then the selves are also going to represent a series of snapshots, maybe selfies, over time. Sorry, that was a bad joke. So as I get to the end of the talk, I also want to conclude by illustrating that perhaps a concept of embodied selfhood could promote aspects of well-being and social justice. So that's kind of just an overview of how I conceptualize the self, and largely based on readings in psychology, some in philosophy as well. And I always like to say, well, okay, so what? Why does it matter that we have these embodied selves? And I wouldn't be do justice to a talk on self without referencing William James. So of course, he has an early conception of multiple selves here. And so his thought is there is an empirical self, and that gives way to the three other selves. And the empirical self for James was the quote-unquote me of personality. And he wrote, in its widest possible sense, a man's me, his empirical self, is the total sum of all that he can call his, not only his body and his psychic powers, but his clothes, his house, his wife, his children, his ancestors and friends, his reputation and works, his land and horse and yacht and bank account. So we can note that this version of the self is based on a very privileged upper class experience of the self, where there can also be not only ownership of one's body, but ownership of other bodies as well. And then James then subdivides this, though, into three different selves: the material self, the social self, and the spiritual self. And the material self is going to be everything that a person could call their own. The social self, so again, body, family, property. The social self is the self known by others, so again, thinking about the self in context of other people. He wrote, a man has as many social selves as there are individuals who recognize him and carry an image of him in their mind. So this, again, suggests that our construct of selves is always ever-changing in the context of other selves. And he wrote that he believed the spiritual self consists of a person's state of consciousness. I'm going to work around the term consciousness in this talk, but that was what he believed. And he said it's everything we think. It includes our emotions and our various states of consciousness. And I think really the take-home message for James was that the spiritual self was the experience of one's subjective reality. So for James, I think the self is partly known, partly the knower, partly object, partly subject. But his initial conceptualization of multiple selves has continued throughout psychology. So what do psychologists study when they study the self? This is a list of different self domains that have been studied in psychology. And I would say that this is how people have attempted to study the self. This may not be 100% correct, right? There's always room for improvement. I like to remind ourselves, even though we're talking about science, it's based off of theories. It's based off of imperfect statistical methods. So again, this is not meant to be the end-all, be-all here. And I'm sure if we look at what this research looks like in 20 years, it will have changed again. So as I move through the talk, though, I'm going to be addressing some key constructs that are going to be directly associated with the construction of an embodied self. So I'm going to be talking to some extent about self-awareness. I have a lot of problems with this term of ownership, but it's the perception of the body and environment as self-related. That in of itself is fine. You'll see how it's going to be applied in the research and why I have problems with it, so we'll come back to that. And then we'll also be talking about emotion, or the convergent experience of interoceptive and exteroceptive stimuli. And I should also add that the basic premise of this research is that the self is a hypothetical construct that presumably has observable behaviors or indicators that are measurable using research tools. These research tools can be based in neuroscience, experimental psychology, or assessed using self-report measures. Ideally, a mix of these tools would be used, and we would look for converging validity across measures in order to understand self. It also may be the case that the self is just too large of a hypothetical construct for neuroscience to adequately measure. We may do better with smaller units of analysis to work with. All right, so let's talk about the brain for a minute. What is an embodied brain? So the brain exists inside of the body, right? It's a structure that's going to consist of networks of billions of communicating neurons that ultimately function to promote the survival of the body and to promote reproduction. And hopefully the evolutionary researchers in the room can correct me if this is not a correct perspective here, but at the bottom line, I think that's what our bodies are for, and that's what our brain serves a purpose of in the body. And the brain is this massive, dynamic, complex network that is sensitive to context and environment. It is always changing. Our field of neuroscience, this past summer, we lost a brilliant researcher, Marion Diamond, one of the first women to get a PhD in the field back in the 1950s. And she was one of the first researchers to show that the brain could change in response to an enriched environment. Her seminal papers on this came out in the late 60s, early 70s, and no one believed her. So that long ago, there was this belief that the brain could not change except with aging, where it would deteriorate, and we know that's not true anymore as well. When Dr. Diamond presented these findings that the brain could change in response to an enriched environment, there was a man who stood up at the end of her talk and he said, "I'm sorry, but the brain cannot change." And she retorted to him, "Well, sir, I have done the research, I have done the science, and I have replicated it, and indeed it can." And from there, we saw lots of research unfold around how the brain can change in response to the environment. So it's, again, we're dealing with all these dynamic and ever-changing constructs, so it's really hard to pin down how can we study a self that's ever-changing, how can we study a brain that's ever-changing. The best we can sometimes do is a snapshot in time. I'm going to talk a little bit about interoception, and that's going to refer to the brain's representation of internal sensations. So the brain has been theorized to create an interoceptive model that serves as a filter for incoming sensory input and subsequent actions in a predictive manner. So the idea that our brains can predict the future based on past experiences. And the brain is going to predict what's going to happen based on processing incoming internal and external sensory events. And this has been referred to as predictive coding. And this notion of predictive coding is relatively new in the neurosciences, and it has significant implications for the conceptualizations of an embodied selfhood. Here's a drawing by my 7-year-old. Actually, I think he was 6 at the time when he did this. And of course, he wrote, "Your brain is in your head." But it's a pretty good picture of the brain. See the corpus callosum. I think this is supposed to be the spinal cord. So he's really encapsulating, so much of our central nervous system that is embodied here. Again, kids they're great scientists and philosophers. So, but back to predictive coding. Predictive coding is going to suggest that the brain processing information as it's related to our bodies is going to do this in a probabilistic manner. As coding, this is the most likely to be me. So using the self almost as a filter based on, again, prior knowledge about interoceptive and exteroceptive stimuli. And so this is useful. Modern-day psychological science has conceptualized, as you guys should realize by now, the self as a multimodal construct that's involving both bodily representations as well as cognitions and emotions. And those cognitions and emotions, there's lots of different theories. Are those cognitions and emotions coming out of the state that our body's in, or because we have the cognition and emotion, we realize the state that our body's in? There's lots of different theories around there. But per the predictive coding theory, different somatic, cognitive, and emotional representations are constantly interacting with each other to try and minimize the system or the brain's prediction errors and reconcile any inconsistencies within the system. And it's doing this in the service of homeostasis. And so such probabilistic representations are going to arise again through this integration of arguably hierarchically organized systems in different brain areas. So I'm going to return to the implications of this theory in a bit, but I first want to address another question, and that is, and this was raised earlier as well by a wise person in the audience, and the question is, how has the self been associated with brain structures and function? And to echo some of the things that Susan already said, I'm going to steal my own punchline and tell you that I am very staunchly against biological reductionism, and I don't think the self can be identified in the brain, and I will explain this in a minute. So this is from Lisa Barrett's recent paper, the image over here, and I'll walk you through that in just a second. But in this paper, Lisa Feldman Barrett is arguing that recent human neuroscience research is going to suggest that self-related processes, actually this is coming from Richie Davidson, that self-related processes are not instantiated in a particular region or network, but rather processed by a broad range of fluctuating brain processes that are not self-specific per se, and that the core, or the minimal self, has been theorized to be processed to brain regions related to interoception and homeostasis, such as the anterior insula, temporal parietal junction, hypothalamus, and other subcortical brain regions. So these are some, I'm worried if I'm not mic'd, you won't be able to hear me, but these are some of the brain regions that were in that laundry list. And right here we have the ventral medial prefrontal cortex, we have the anterior cingulate cortex, the dorsal medial prefrontal cortex, the overall cingulate cortex, the middle cingulate cortex. We have the motor cortex and sensory cortices as well as some pre-motor and sensory processing. And so that's going to be a sagittal section of the brain. If we cut the brain in the middle and looked at it, that's what we're seeing. This is, of course, is the corpus callosum connecting both hemispheres, and these are ventricles where our cerebral spinal fluid is stored. If we go down below, this is the lateral view of the brain. We see some of the same brain regions, but mostly we're seeing things from the lateral view and some new regions here. This is V1, and this is really involved in visual input as well. And so the basic idea is we have all these brain regions, but they're not going to support one singular process. So the philosophers who believed in mental faculties, that's an outdated theory that there's going to be a one-to-one relationship with various brain regions and specific functions. So these are all going to be very multifunctional brain regions, and in a given context, doing a given task, they're going to be activated in a specific pattern, in a specific way. That, again, is not specific to one specific emotion or function. I couldn't say working memory exists in the prefrontal cortex. Prefrontal cortex may be part of working memory, but there's other parts of our brain network that are supporting that. I couldn't say there's a love spot in the brain or there is a happiness spot in the brain. So again, the brain is going to be working in very complex patterns of activating groups of neurons that are firing in distinct ways. And what we don't understand as neuroscientists yet is how does this work? And so the theory of predictive coding is relatively new, and it's probably going to be outdated in a decade, but people are going to continue to work on this as a unifying theory, I think. So, and this just kind of illustrates the complexity of what we're doing. This is from a paper from 2007. And the goal of this paper, they were just trying to figure out, okay, when we look at a picture of ourselves or if we look at a picture of someone else, what happens in the brain? And it turns out there is just this complex cascade of bidirectional brain activity that's happening. So I won't walk you through this whole figure. It's a great figure, though. I love it for many reasons. But you can hopefully see the complexity of just processing a single visual stimuli. Now, try and say, instead of a visual stimuli, put the word self or selves here. What would that look like? I don't think we can do it. But again, even though we can't do it with the tools we have now, maybe we can do it someday in the future. I don't know. But I think there are, if we can start to think about the self as multiple selves that come out based on the context at hand to achieve the specific job that needs to be done, we can start to think about how is the brain going to use the self as a filter to obtain homeostasis. So think that's about what I want to say here. And my take-home message should be that psychological functions are implemented in a network of biological structures. So I chose my language carefully here. I'm saying that our psychological functions are implemented in biological structures. I'm not reducing them to the biological structures themselves, okay? And we could also say that perhaps the embodied selves are represented in the mind, and that the brain gives way to the mind. And this is arguably where the metaphysical narrative selves reside. So to illustrate this, these are, it's a little hard to see with the lighting, but these are sculptures by Franz Xaver Messerschmitt, and he lived from 1736 to 1783 in German. He was a German Austria sculptor, and he was most famous for his character heads. And so these are a collection of busts with faces in extreme, contorted in extreme facial expressions. And you can see that there may be a core self that emerges, but each of these sculptures are different, representing different aspects of his selfhood. And he may have had a digestive disorder, or interestingly, a disorder in his throat that led to a lot of discomfort. And so that's captured in a lot of these. But when I saw these sculptures this past fall in person, I was just blown away by them. And I'm like, this is capturing our multiple identities and characters and selves. And I think there's a lot that art can do to help represent our embodied experience of selves. So this is just one example of that. And I wanted to talk just a little bit about selfhood and emotion. And my argument is that emotion or affective experiences are going to shape the lens through which we view the world, and thus it's going to impact the construction of our self or selves and how those selves interrelate with others. So of course, the cartoon, he says this plugin was very expensive, it had better work, and these are all emotional filters. A question that came up was sort of about an embodied experience of emotion, and can emotion exist in the body? And there was a really interesting study, I think this came out in about 2014, and what participants were asked to do, sorry, I'm at a weird angle, I can't see, and I'm used to just like standing in front of the slides and pointing and gesturing everywhere. So I'm doing my best I can from behind the podium, but if you look at the left of the screen here, it's your left. It says this is what participants had to do for the study. They had to use the pictures below to indicate the bodily sensations you experience when you feel sadness, and then there's all these other words as well. For this body, please color the regions whose activity becomes stronger or faster. For this body, please color the regions whose activity becomes weaker or slower. So they were trying to figure out, can we figure out where in the body emotions are activated or deactivated, and then they made this map. And so since love came up in a previous conversation, here is love, and arguably the womb here is involved, and in Hebrew, the root for the word room is, of course, rem, which translates into compassion. So just trying to do my best here to connect some of our learnings from the Old Testament with modern day science. So these are pretty striking. This was cross-culturally validated as well. So I think it does suggest that our emotions are experienced in a very embodied way. So, all right. And the next question that I have goes back to my original thought experiment. What happens when we put ourselves into another body? And this was tricky to find an answer for in the psychological literature, so I'm going to do the best I can here. And there are some studies that folks have been doing in my field related to trying to understand, they're using the term ownership. And this is what they say. They say ownership concerns the experience that one's own body and environment are perceived as personal and closely related to one's self. And researchers have suggested that neural correlates of ownership, this is from Noroff and Bernpohl in their 2004 paper, but that ownership, that we can look at neural correlates that are going to involve the right parietal cortex, this part of my brain, and also the ventral medial cortex. And one thing we know from a lot of neuroscience and neuropsychology research is that the right parietal cortex is implicated in spatial processing and perception. It's also really involved with how we locate our own selves in space, or proprioception. And so accordingly, if we have a lesion in the right parietal or the right temporal parietal cortex, we can see body disturbances. One would be called anosognosia, which is the denial or unawareness of a limb, or a somatonosia, which is going to be the misidentification or denial or ownership of a limb. So we can have disruptions to brain functions that influence how we perceive our body in space, or the lack thereof. And of course, for people who experience these disturbances, they're immensely upsetting. So that's sort of this idea that we can start to try and understand how our self is related to the ownership of our body. Where this breaks down for me is I'm going to talk about some research where people put themselves in other people's bodies, and the thought is then that that conception of their body becomes merged with their own, and I think ownership is absolutely the wrong term for this. So in this first image here, there is something called, this is going to be called a rubber hand illusion, and it's a little hard to see with the lighting, but essentially someone has their real hand and their rubber hand, and the experimenter is touching both and looking to see how someone processes the differences in hands. In this task, the experimenter is touching the participant with a Q-tip while they're watching somebody who has a different skin, a darker skin color, being touched on the face with the Q-tip. And so the idea here is to try and shift and merge the perception of different bodies into one's own self. And the most extreme form that I've seen of this in the literature is with virtual reality. And here we have a lighter skinned person who then virtually becomes either purple-skinned or they're a darker-skinned person. This research was done, I believe, in Spain. And so what they did was, before they entered the virtual reality, participants did an IAT, or implicit associations test, to evaluate their racial bias. This test was developed by Mahzarin Banaji at Harvard. It's very well known. And so they found that when someone took on, essentially put their body into a darker skinned body, that reduced racial bias. And so this question again goes back to this original thought experiment. What happens to ourselves when we put ourselves in another body? And maybe the idea is that our self can change. And this, of course, ties into other themes that we've heard in our talks around empathy and interconnectedness and compassion for other people as well. There are a whole host of issues and problems with this research as well, but the implications are, I think, are quite intriguing on thinking about how do we reduce racial bias from a perspective of embodied selfhood. So, so going back to predictive coding, how we recognize ourselves and what governs our sense of ownership over our bodies is still it's very much in debate in the psychological and neuroscience literature. However, with our recent interest in predictive coding, we may see that there could be a unifying theory of brain function in understanding ourself and how our selves could be related to other people's selves and bodies as well. And so there's various theories about how these different kind of forms of other self-embodiment is feeding into our own interoceptive and exteroceptive stimuli that is part of the predictive coding model. So, so where do we go from here? One of the questions that I have is, arguably, we are experiencing, particularly in urban areas, a decentralization of community. The 2017 World Happiness Report, there's a chapter dedicated to the fact that Americans are some of the least happy people in the world. So my take on that is that we have our elements of community and our interconnections with other people has started to break down. But from a neuroscience perspective, again, of an embodied self, what can we do about this? And other disciplines may have other answers, but I want to see us work towards developing healthy, interconnected selves. So we've already seen a range of interventions coming from positive psychology with regard to ways to enhance gratitude, savoring, empathy, perspective taking, and social connectiveness. And my task to the community is now, can we add a neuroscience conceptualization to try and really add to this evidence base that maybe these methods are gonna help? And can we develop neuroscience-informed interventions to decrease the psychological boundaries between self and other? So, for example, there's a recent paper that came out regarding the effects of loving and kindness meditation. And with this the study was an EEG, an electroencephalography-based study, and essentially the researchers showed people images of their own self and other people's self and recorded their brain response. And their brain response was able to identify and distinguish when they saw a picture of themselves and other people's selves. Now, participants did loving kindness meditation for an extended period of time, and after they repeated this ERP study, and they found that the distinction between self and other diminished at the neural level. So this really suggests to me that our conceptualization of our embodied selves are very malleable, and that they can respond to interventions, and these don't have to be pharmaceutical interventions. So, other ideas people have had is we need to just increase intergroup association and opportunities for dialogue, and I think that's really, really critical as well. And now this new area of research suggests that virtual reality training could be important also. Can we start to use video games for good? So, and my work on this was deeply informed by my graduate school mentor, Wendy Heller, my colleague, Kevin Hellman at North Shore, where we've been studying somatic symptoms in women with pain conditions, and then also, of course, the researchers in my lab, graduate students Kelly Plasnik and Ian Krillis, as well as the undergraduates who've been working with us as well. So, and there I am testing out our EEG equipment, and I had a good research assistant in for the day. It's my son. So. And thanks to all of you for being here today, and I look forward to hearing your questions and critiques and commentary in a little bit. So thank you.